Good evening. Welcome to my program. I'm Dinesh Vijayvardhana. Today we're going to continue from my last video, which was from we discuss and introduce what thermodynamics is, and so today we're going to go further, a little bit more detail into thermodynamics and what are the characteristics, what type of systems such as that. So let's get into the topic. I have written down what thermodynamic system is. Like we introduce into thermodynamics. What we need to know is what is a thermodynamic system is. So thermodynamic system is this is defined as a quantity of matter or a region in space that is of interest. So quantity of matter. So quantity of matter means like it is a system. So it can be either enclosed or disclosed. So this is the thermodynamic system, and it is a quantity of matter. So it does have mass associated with it. It could be either any sort of mass within the boundary. So that's the system, thermodynamic system, or a region in the space. So there can be different type of thermodynamic systems. So it could be a region in the space, or it could be a enclosed system, like a thermoflask, something that man-made stuff. So basically, thermodynamic system is defined as a quantity of matter or region in the space that is of interest. So that is basically the definition of thermodynamic system. So now let's see what are the characters within that system. So thermodynamic system basically have the main thing it has is a system itself, and then the boundary, outside boundary. Outside boundary can be either can be an imaginary boundary or unimaginary boundary, real or imaginary boundary. So basically the imaginary surface could be either gas or vapor or any other imaginary surface. Like for example is like world has atmosphere. World has atmosphere, and this is space there. So between space and the world is atmosphere. The atmosphere is the boundary. The world is the thermodynamic system, because everything within the world there is thermodynamic changes, the environmental changes, but nothing. There is relation from outside to inside. So that is just the basic explanation of the thermodynamic system. So now let's discuss further into this. So it has a boundary, and then it got surrounding. So between the system and the surrounding, this boundary. Surrounding is actually the space wherever the thermodynamic system is located, and the outer space is called the surrounding. So this is external space or the matter. So when we discuss the world, that is a good example of so let's consider this is the world. So that's the world, and that's the environment, that is the atmosphere, and that is the space. This is the space, outer space. And there is the sun rays coming in from outside. The sun rays. For example, let me show it to you more properly. So if you see the world, that's the atmosphere, and that's the space, and that's the world. So there's a lot of temperature and atmospheric changes within the world. There is, inside the world is so hot, and the atmosphere layer is outside, and then you got the space, and through the space there is sun rays coming in, and that gives in the energy into the world. That gives in the heat energy to the world, and also the light energy to the world. So the actual the mass does not change within the world, but it does change the energy, the temperature inside the world, the seasons inside the world, all changes through sun rays. So this is a thermodynamic system. This is also the thermodynamic system, and that's the most closest thermodynamic system that we can see. And then let's discuss further into the system what type of thermodynamic systems are. Now, there are three types of thermodynamic systems. First is closed system. Closed systems. Second one is open system. Third one is called isolated system. Now, if we discuss so basically thermodynamic system is a quantity of matter that energy can be transferred in or out, or mass can be transferred in or out. It depends on the type of system. So that's basically a thermodynamic. So thermodynamic system has a system inside, and then you got the boundary, and then you got the surrounding outside. So with the first category of closed system, basically the mass of the system. So let's have a better description. So this is the system, and this is the boundary, and this is the surrounding. So inside the system, there is a mass. It could be air, it could be solid, whatever. The mass does not change in closed system. Okay, but energy can come in and out. So the energy, that's the energy coming in or energy coming out. E in, E out. So that can happen in a closed system, but the mass is constant. So the actual mass of the particles or whatever inside is going to be constant. So that's the basic term of closed system. You can have even examples for that. So basically a balloon filled with air. Okay, examples for the closed system is a balloon. Okay, these are examples. Balloon filled with air. Okay, it can even be a pressure cooker. Even a gas, like a cylinder, like a piston within the cylinder is also can be considered as a closed system. And now let's go to the second one. Is an open system. Open system basically is the mass is not constant. The mass can be also changed. It can change, and also the energy can also change. So energy transfer to the system also happens in, and mass transfer in and mass transfer out. So that's basically open system. This one is mass is constant, the second one is mass can be changed. So there's a lot of examples for this type of open system. For an open system, basically you can consider like air compressors, diffusers, turbines, engines, petrol engines, so boilers. So those are the examples for open system. Now the last one is the most uncommon one. It's less example. Basically in that one, neither mass, neither M or energy is transferred. So there's no energy or mass transferred within that system. So that's why they're called isolated system. There are few examples for that. One good example is a thermal flask, which thermal flask. Because thermal flask, you put the water in and you close down. There is no transfer of energy from outside to in, and this quantity inside the flask is exactly the same. It's not going to change. Of course, when the flask if the seal is broken, the energy transfers, but basically the term is that no energy is transferred to outside. So that's the most correct scenario. So thermal flask is the example for isolated system, and the second one is the universe, or the universe. Because with the universe, let's consider the whole universe, and this is our world, and there are stars everywhere. So when you consider the universe, if you consider everything in the universe, okay, if you consider every single thing in the universe, the mass going to be same, the sigma m, which means the total weight of the universe is sigma m, which is not going to change, so constant. And also the energy, so there is no energy coming into the universe from outside. So everything happens inside the universe. The Big Bangs or anything happens inside the universe is same. So within the boundary. So there is no transfer of energy or mass from outside. So therefore it's an isolated system. So thermal flask and universe can be considered the last category. Now we will discuss in a more problematic way in our next lesson. So thank you for listening, and we'll see you next time. Thank you. Bye.